of normal P1
Here
tracking.
we have a majestic liftoff of LVM-3 M4 rocket carrying India's prestigious Chandrayaan-3 spacecraft.
So India has a long way to go in that department, yes. But I know of no greater force than ambitions in space that can operate on the economy of a nation, because tomorrow's economies will pivot on innovations in science and technology today.
Welcome to Spaceverse. Join us on an exhilarating cosmic odyssey where we unravel the mysteries of the universe, from the wonders of our own solar system to the farthest reaches of deep space. Subscribe now, hit that notification bell, and embark on an extraordinary journey with us through the infinite wonders of Spaceverse. I'm thrilled that India didn't follow the crowd and land on the same old lunar spots everyone's been to before. That would have been rather mundane, wouldn't it? Instead, they set their sights on a place untouched by human exploration, the mysterious South Polar region of the Moon. When Neil deGrasse Tyson spilled the beans about India's mind-blowing discovery on the Moon, the entire world perked up and paid attention. Their destination? The South Pole, a location chosen to investigate and confirm the presence of water concealed within those lunar craters. But this isn't just your run-of-the-mill celestial news. It's a groundbreaking discovery that's reshaping our understanding of Earth's lunar satellite. So, let's dive right in to uncover what India stumbled upon and why it's causing such a cosmic commotion. Now let's take a trip down memory lane to Russia's inaugural lunar touchdown. In the grand chronicles of space exploration, there are moments that etch themselves into our collective memory, and one such milestone unfolded in the early days of 1966. It was the awe-inspiring achievement of Luna 9, a Russian spacecraft that marked humanity's very first gentle landing on the lunar surface. But this mission was no ordinary affair. Luna 9 sported a design that was both innovative and strategic, resembling a spherical capsule with a weight of 99 kilograms and a diameter of 58 centimeters. This lunar pioneer came equipped with 4 intriguing pedals that served a dual purpose: to stabilize the craft upon landing, ensuring it remained upright, and to unveil the critical instruments hidden within. Luna 9 carried a treasure trove of cutting-edge equipment, including a radio system for communication, advanced solid-state detectors to measure radiation, and a crucial thermal control system to regulate temperature fluctuations. Yet the crown jewel among its instruments was the television camera strategically perched on a platform with the ability to rotate and scan the expansive lunar landscape. As the world held its breath, Luna 9 sprang into action, and the results were nothing short of spellbinding. The images it captured revealed a lunar terrain of stark beauty, a dramatic contrast of rugged craters set against rolling hills, a landscape untouched by the hand of humanity. These images were so captivating that the Jodrell Bank Observatory in England received them, and soon after, they graced the front pages of the Daily Express newspaper, leaving the world in awe of our closest celestial neighbor. However, Luna 9's mission went far beyond just capturing eye-catching visuals. It embarked on a vital scientific odyssey. It meticulously recorded the lunar temperature, registering the extremes from a bone-chilling negative 153 degrees Celsius during the Moon's frigid night to a scorching 123 degrees Celsius in the daytime. These measurements unveiled the Moon's almost non-existent atmosphere with a pressure that was less than a billionth of what we experience on our home planet. In addition to temperature data, Luna 9 also acted as a cosmic radiation scout, disclosing a daily dose of approximately 30 roentgens. But Luna 9 didn't confine itself to mere observation. It actively engaged with the lunar soil, conducting a rudimentary but illuminating soil mechanics experiment. Employing a rod to exert pressure on the Moon's regolith, the spacecraft unveiled a remarkable discovery. The regolith exhibited a bearing strength of at least 0.4 kilograms per centimeter square. This pivotal revelation hinted that the lunar surface possessed the robustness to support the weight of potential future landers and even rovers. As with all great adventures, Luna 9's mission had its finite limits. After a relatively brief sojourn of about 3 days on the lunar surface, the craft's batteries were drained. Nevertheless, in its brief sojourn, it beamed back a total of 8 captivating images and numerous troves of invaluable data. Luna 9's remarkable journey paved the way for Luna 13, which touched down later that memorable year on December 24th. This subsequent mission carried the torch forward, conducting analogous experiments and deepening our comprehension of the enigmatic Moon. But let us now fast forward to the unforgettable Odyssey of Apollo 11, an event that irrevocably altered our perspective of the cosmos and our position in the vast universe. This extraordinary journey commenced on July 16, 1969, with the launch of the Apollo 11 mission from Florida's iconic Kennedy Space Center. As part of the ambitious Apollo program, the mission's primary goal was nothing short of transporting humans to the lunar surface and ensuring their safe return to Earth. Apollo 11 marked humanity's inaugural endeavor to demonstrate the capability to journey to the moon, alight upon it, and then safely journey back to our home planet. This monumental task was entrusted to three remarkable astronauts: Neil Armstrong, the mission commander and the trailblazer who would forever be etched in history as the first human to step foot on the moon's surface; Edwin Buzz Aldrin, the lunar module pilot who would follow in Armstrong's historic footsteps; and Michael Collins, who played the pivotal role of orbiting the moon in the command module while his intrepid colleagues embarked on their lunar exploration. A masterpiece of ingenuity and innovation, Apollo 11 comprised three indispensable components. The command module bore the name Columbia, serving as the sole vessel designated for the return voyage to Earth, safeguarding the astronauts on their homeward journey. Meanwhile, the service module acted as the mission's lifeline, ensuring a continuous supply of power, oxygen, water, and propulsion to sustain Columbia. In contrast, the lunar module, bearing the moniker Eagle with its two-stage design, shouldered the monumental responsibility of ferrying Armstrong and Aldrin from lunar orbit to the enigmatic surface of the moon and back to rendezvous with the command module. Apollo 11's epic odyssey spanned approximately 8 awe-inspiring days, a period teeming with anticipation, astonishment, and groundbreaking revelations. Following its departure from Earth, the spacecraft executed a celestial dance and aligned itself with the moon's orbit by July 19th, setting the stage for the mission's next captivating chapter. On July 20th, Armstrong and Aldrin cocooned within the lunar module and initiated their descent, eventually alighting on the tranquil plains of Mare Tranquillitatis, famously known as the Sea of Tranquility. The entire world held its breath as Armstrong stepped onto the lunar surface and uttered the immortal words, "That's one small step for man, one giant leap for mankind," imprinting his foot on the lunar regolith. Shortly thereafter, Aldrin joined him, and together they spent approximately 2 hours conducting experiments, collecting priceless samples, unfurling the American flag, and erecting scientific instruments. During these historic moments, they even engaged in a memorable telephone radio conversation with President Richard Nixon. Meanwhile, in the command module, Collins diligently continued his lunar orbit, conducting his own set of experiments and capturing photographic evidence of the moon's captivating surface. Upon the conclusion of their lunar tasks, Armstrong and Aldrin faced their next challenge, reuniting with Collins. This rendezvous unfolded seamlessly on July 21st. Subsequently, the astronauts bid farewell to the lunar module, charted their course out of the moon's gravitational embrace, and commenced their homeward journey, culminating in a triumphant splashdown in the Pacific Ocean on July 24th. Fast forward to the remarkable Chandrayaan-3 mission by India in 2023, a moment that captivated the world and etched a new chapter in the annals of space exploration. Chandrayaan-3's distinction lay not only in India's accomplishment, but also in its global significance, as it aimed to make a historic touchdown near the moon's enigmatic South Pole, a region veiled in cosmic mystery. The enigmatic South Pole held the allure of profound scientific revelations while presenting intricate challenges that demanded ingenious solutions. The Chandrayaan-3 mission, a marvel of design and ambition, was composed of 3 distinct yet intricately interconnected components. First in this cosmic ensemble was the Vigilant Orbiter, an eye in the sky equipped with 8 cutting-edge scientific instruments. Its primary mission was to maintain a watchful gaze upon the lunar surface and atmosphere, all from a pristine circular orbit hovering at approximately 100 kilometers above the moon. Accompanying the orbiter was the Intrepid lander, affectionately named Vikram in honor of Dr. Vikram Sarabhai, the visionary architect of the Indian Space Research Organization, or ISRO. Vikram embodied more than symbolism. It was a rugged workhorse equipped with 4 vital instruments. These instruments were poised to record invaluable data concerning temperature variations, seismic activities, plasma density, and surface composition in the vicinity of its designated landing site. And last but certainly not least, there was Pragyan, the the rover whose very name derived from the Sanskrit word for wisdom, which reflected its purpose. Pragyan was an embodiment of knowledge on wheels tirelessly traversing the lunar terrain. Its two onboard instruments toiled diligently to unveil the moon's mineralogical secrets and the elemental richness hidden within its soil. The celestial journey commenced on July 14, 2023, casting its spell on the skies above the Satish Dhawan Space Center in Sriharikota, India. A roar of power erupted as the dependable Polar Satellite Launch Vehicle, also known as the PSLV rocket, assured Chandrayaan-3 on its maiden voyage. However, the path to the moon was far from direct. It entailed a delicate, week-long dance around Earth, gathering momentum and biding its time. On July 21, 2023, Chandrayaan-3 embarked on the next phase of its odyssey. Executing a meticulously calculated trans-lunar injection maneuver, the spacecraft positioned itself to be captured by the moon's gravitational embrace, propelling it into an elliptical orbit around our celestial neighbor. Yet, the ISRO team's work was far from over. Over the ensuing weeks, a series of precisely executed orbit-raising and orbit-lowering maneuvers enabled them to masterfully navigate Chandrayaan-3. Their ultimate objective: to position it in an optimal circular orbit at approximately 100 kilometers above the moon's surface by August 19, 2023. An objective skillfully achieved. Vikram accomplished a remarkable feat, finding its snug spot nestled between two lunar craters, Simpilia Sen and Manzinas C. This region, renowned for its extreme conditions, boasts bone-chilling temperatures that can plummet to a frigid -240 degrees Celsius. Sunlight graces this lunar terrain sparingly like a rare luxury, only occasionally casting its gentle glow upon the lunar surface. In the wake of its grand lunar touchdown, Vikram wasted no precious moments. The lander gracefully unfurled its solar panels, akin to wings stretching out after a long flight, and extended its antennas. These extensions formed a celestial communication bridge linking with the orbiter above, and by extension, with the eager researchers and scientists back on Earth, who yearned for every morsel of information. Yet, the Lunar Odyssey had only just commenced. After allowing a brief interval for the lunar dust to settle, much like waiting for earthly dust to come after a gust of wind, the rover Pragyan received the green light. Rolling down from Vikram's ramp, the rover emerged onto the lunar landscape, reminiscent of an explorer's first steps onto an untouched island. Pragyan was granted a fortnight, a solitary lunar day, to execute its mission. Engineered to journey up to half a kilometer from its parent lander, the rover was a virtuoso in autonomy. Equipped with onboard cameras and sensors, Pragyan possessed the visual acumen and instincts to navigate the rugged and unpredictable lunar surface, ensuring it gracefully bypassed obstacles and never found itself entangled in a lunar quagmire. In the realm of cost-effective lunar exploration, India's Chandrayaan-3 mission stood as a beacon of financial prowess, boldly venturing into the uncharted lunar territory of the South Pole while skillfully balancing its budget. With a lean expenditure of just $74 million, this mission showcased India's exceptional ability to unite financial efficiency with cutting-edge space innovation. To grasp the financial intricacies, consider the figures unveiled by K. Sivan, the former chairman of ISRO. The overall mission expenditure amounted to approximately $74 million, which when dissected revealed that the lander, rover, and propulsion module consumed about $30 million, while launch services accounted for around $50 million. This astute budgeting shone even brighter when juxtaposed with the Chandrayaan-2 mission that, despite its 2019 landing failure, carried a more substantial price tag of approximately $96.5 million. Comparisons with other international lunar expeditions further underscored Chandrayaan-3's cost-effectiveness. Russia's Luna 25 mission with a similar South Pole target, but an unfortunate crash, came with a price tag nearing $200 million. NASA's ambitious Viper rover project, slated for 2024, projected a staggering cost of $433.5 million. China's Chang'e 4, which successfully touched down on the moon's far side in 2019, carried a bill of around $180 million. The secret behind Chandrayaan-3's budget-friendly triumph lay largely in its compact and lightweight design. With the combined weight of the lander and rover totaling a mere 1.4 tons, Chandrayaan-3 was notably lighter than many of its international counterparts. A notable comparison can be made with NASA's Viper rover, which alone weighed approximately 1 ton. This strategic emphasis on lightweight design significantly curtailed multiple associated costs, most notably those tied to launch and fuel expenditures. Yet, the advantages extended beyond mere weight considerations. Chandrayaan-3's financial astuteness was equally attributed to its judicious utilization of pre-existing technology. India had at its disposal the GSLV Mk3, not only the nation's most robust rocket, but one that had already proven its mettle in numerous prior missions. Moreover, instead of commencing from scratch, the lander and rover for Chandrayaan-3 were derived from and improved upon the designs originally crafted for Chandrayaan-2. As August 23, 2023 dawned, the world watched in eager anticipation, bracing for what lay ahead. It marked the onset of what ISRO Chief Samanath aptly described as the 17 minutes of terror. Within this nerve-wracking time frame, the lander named Vikram undertook the Herculean feat of decelerating from a breakneck 1.6 kilometers per second to virtually a standstill before gently embracing the moon's surface. In the absence of real-time communication or human intervention, Vikram relied solely on its onboard systems to make critical decisions. It adeptly adjusted its thrust, assessed the moon's undulating terrain, and executed a flawless landing. In a triumphant display of technological prowess, Vikram achieved this remarkable feat, subsequently paving the path for the rover and christened Pragyan to embark on its Lunar Odyssey. Yet, the rover was not without its own set of challenges. It adeptly navigated the moon's dusty and rugged topography, artfully circumventing obstacles while maintaining an unbroken line of communication. Nonetheless, the journey didn't culminate with a triumphant landing. The mission operated on a strict timeline with a mere 14 Earth days, equivalent to 1 lunar day to execute its lunar surface operations. Within this compressed time frame, the lander and rover raced against the clock, conducting experiments, scrutinizing lunar soil, monitoring temperature fluctuations, and an array of other tasks. Moreover, they bore the immense responsibility of promptly relaying this invaluable data back to Earth. There were many obstacles to overcome, including the lunar surface's temperature ranging from a bone-chilling negative 180 degrees Celsius to a sweltering 100 degrees Celsius, sporadic communication blackouts, the constant threat of solar radiation, and the complex chore of carefully regulating power usage. The Indian moon mission gets high marks from Neil deGrasse Tyson. When India's Chandrayaan-2 mission prepared to make an indelible imprint on the lunar canvas in 2019, Neil deGrasse Tyson voiced his support and hope for the endeavor. He then broadcast his farts to the world, saying, "The Chandrayaan-2 mission is nothing short of monumental." As a result, India is in a prime position to become the 4th country in the world, after the United States, Russia, and China, to accomplish a soft landing on the moon. The boldness with which it explores the unknown terrain of the moon's south pole is, however, what truly sets it apart. But why does the lunar south pole have such importance? Tyson, who has a knack for breaking down complex scientific ideas, shed some light on the situation. He gave some light on the significance of the area, explaining that the south pole of the moon is like a treasure trove for scientists. Water ice, which can support life and be used as rocket fuel, may be hidden within the craters that are always in the shade of their walls. And the equipment had to be state-of-the-art in order to accomplish such a lofty goal. A lunar surface thermometer, or RALST, was on board with the lander Vikram. This instrument collected heat data from the lunar surface around the South Pole in order to create a thermal map. Since water ice might be concealed in areas with low enough temperatures, this information was vital. Vikram also had a laser retroreflector array, or LRA, installed, useful for relaying laser signals from spacecraft or telescopes in orbit back to Earth. Scientists were able to use this interaction for more than just talking to one another. They were also able to calculate distances on the moon and investigate the mysteries of lunar gravity and spin. After that, there came Pragyan, also known as the Rover, an explorer who was equipped with modern-day instruments. It was equipped with both an alpha particle X-ray spectrometer, or APXS, and a laser-induced breakdown spectroscope, or LIBS. Through the use of a laser, the LIBS was able to vaporize minute amounts of lunar soil and then analyze the resulting light to determine the soil's composition. However, the APXS detected a wide range of elements in the soil, from oxygen and magnesium to more exotic ones like titanium and chromium. Hydrogen and carbon were among the elements they looked for as a group in their search for water. But Pragyan was more than just dirt and elements. It also had stereo cameras or scans for eyes. This camera took high-resolution pictures of the lunar landscape, which were useful for mapping and recognizing potential hazards. In addition, the surface was displayed in 3 dimensions, highlighting promising areas for future sample collection and in-depth study. What this mission yielded was nothing short of miraculous. In the vicinity of the South Pole, Pragyan discovered sulfur, an element not often present on the Moon. Speculations were raised as to whether or not this would indicate the presence of water, ice, or other flammable compounds in the area. Pragyan also looked for hydrogen, a chemical signature of water with its sensors. Intriguing information was also shared by Vikram. Daytime highs reached a scorching 121 degrees Celsius, while overnight lows hovered at -156 degrees Celsius. This information was crucial in deducing how water, ice, and other resources could survive in such a hostile environment. As Vikram made progress on the lunar surface, the propulsion module was busy in orbit, providing a bird's-eye view of the Moon and Earth. It also set out to research the polarimetry of Earth's atmosphere, in addition to capturing high-resolution photos of the lunar surface. The goal is to learn about atmospheric events and climate by gaining an appreciation for the scattering properties of our atmosphere. To add to the excitement of these findings, the propulsion module transmitted some stunning imagery back to Earth. These included one that appeared to depict a possible lava tube in the area of the Schrödinger crater. Why did this matter? Lava tubes, which are gigantic tunnel-like structures generated by flowing lava, are thought to provide shelter from cosmic radiation, temperature extremes, and micrometeorite strikes. This makes them excellent prospects for potential lunar colonies in the far future. Human exploration and long-term colonization of the Moon received a slight boost with the finding of this suspected lava tube. And now, before we wind up, let's pause to reflect on the incredible achievements of the space race and India's outsized role in it. Neil deGrasse Tyson's spotlight on this discovery reminds us that the universe still holds many mysteries waiting to be unraveled. So don't forget to like, share, and subscribe to stay updated with our latest space explorations and mind-boggling discoveries. Until next time, Spaceverse bids you farewell, and may your curiosity continue to soar among the stars.